So back in the day, when I used to do some Macromedia Flash programming, the company that I was working at, Coco Interactive, used to send out these Christmas cards, these animated Christmas cards, and oftentimes there was this snowy snowflake effect in the background of the Christmas card. And this was achieved in Macromedia Flash, wherein each of these snowflakes was an individual instance of a movie clip on the timeline, and the individual movie clips were responsible for updating their vertical positioning as well as the horizontal positioning. So not only do these snowflakes move from top to bottom, but if you look closely, they're moving back and forth along a drop line. And each one of these moves at a slightly different speed. You can see there's some difference in size and some opacity. And it's a fun way to kick off the 2021 new year. I thought I would try to recreate this kind of a concept using Angular and some CSS animations. So let's take a quick look at how this is working under the hood. If we jump into our app component, all I'm going to do in the app component is generate 150 different snowflake configurations. Each snowflake configuration exists as a horizontal location on the screen. This is going to be viewport units, so I'm essentially starting from the left and randomly going to the right. And then I'm going to pass both a depth and a speed to each instance of my snowflake component. And these are just 1 to 5 abstractions that the snowflake is going to use to add some variance, right? Because if we look at the animation, you'll see that some of them are tiny, some of them are larger, and the larger ones are a little bit more transparent, and the smaller ones are more opaque. So we're going to use that. And then, of course, they're traveling at different speeds. And this all comes together to create a more natural, snowy experience. So the HTML for my app component simply takes this array of snowflake configurations, performs an ng-for, loops over it, and then creates a snowflake instance on the page, passing in both the depth and the speed, and then we don't have to pass in the horizontal placement of the snowflake drop line. That we're going to control in the app component. So the snowflake itself is essentially a vertical band on the screen. We're going to position it horizontally inside the app component, but then internally to the snowflake, it's going to control the size and the local back and forth speed and the vertical speed using these inputs. All right, so let's jump into our snowflake. So if you think about the snowflake, each snowflake here travels both from the top of the page to the bottom of the page, and then, as I said before, it travels back and forth along a drop line. Now, the actual flake itself doesn't move. Instead, it has a series of nested parents, and each of the parents is responsible for moving the flake in a particular axis. So if we look at the HTML for the snowflake component, here is the actual snowflake. This is the circle that is of a particular size and a particular opacity. And you'll see that it has two parents, two ancestors. It has a horizontal track, and this parent is responsible for moving the snowflake back and forth from left to right, and a vertical track. And this parent is responsible for moving the snowflake from the top of the screen to the bottom of the screen. And it's going to be doing that using CSS animations. And the animations will repeat indefinitely. So essentially, every time a snowflake hits the bottom of the screen, it automatically then starts coming back in from the top of the screen. And we can look at these elements here behind the scenes at the animations. So the vertical track uses an animation called snowflake vertical animation. The horizontal track uses a snowflake horizontal animation. And if we jump down here to the bottom, we can see what those two different animations are doing. The vertical animation is moving the element from the top of the screen, 0%, to the bottom of the screen, 100%, using the top property. And the horizontal animation keyframes are responsible from moving from the left-hand side of the drop line to the right-hand side of the drop line, and then back to the left-hand side of the drop line. And that way we get that back and forth wave-based animation. So we're going to be performing two different CS animations in parallel, one that's continually moving from top to bottom, and one that's moving back and forth horizontally. And again, together, we get this nice, natural, organic, snowy effect. Now, By default, the animation has a 5-second duration vertically and a 3-second duration horizontally, but we don't want every snowflake to be moving at the same speed and in the same direction at the same time. Otherwise, this would look wholly artificial. So what we're going to do is actually override some of these animation properties using inline CSS attributes in our Angular code behind. And you can see that here. I'm overriding both the duration and the delay for each one of the animations. The duration is the speed it takes for an individual, the speed it takes for an instance of the animation keyframes to come to completion, and the delay determines where within that timeline the animation starts. If we had no delay, what we would see is that all animations start at the top and start going down together, which would look, again, wholly artificial. So what we want is some snowflakes to start higher and lower and in the middle. And by including a delay there, it allows them to all start at various portions of the timeline, even though each element actually has the same timeline. Now, the snowflake component is a pure component, meaning it's using the on-push change detection, so we only have to do something when the inputs change, and really what we're going to do is just translate these depth and speed abstractions into something that is more appropriate for our CSS consumption. And nothing here is too fancy. It's basically just brute force number translation. You can see here that with the speed, I'm setting the vertical duration to different values. I'm also setting the horizontal duration to different values. So again, we're moving both from the top to the bottom, but then also back and forth at the same time using those two different CSS animation keyframes. Similarly, the depth, I'm just switching over the depth and setting the size and opacity of the flake itself. Remember, the flake doesn't move, but it is styled. Now, again, because we don't want all of the animations to start at the exact same moment in the exact same place, we're adding some randomization in the delay. So essentially, we take the duration of each animation and we delay it by a negative fraction of that duration. So for example, if the vertical duration is 5 seconds, we're going to randomly start or randomly assign a delay of negative something 5 seconds. So negative 2.5 seconds, negative 3 seconds, negative 4.7519 seconds. And what that's going to do is essentially start the animation at some point in its timeline, allowing each to start at the same time. So if I refresh the page here, you'll see that all of the animations are kind of naturally spread throughout the entire range of the CSS keyframes. Now, even though this is just a CSS-based animation, it's actually pretty intense for the browser. And if I have this open for more than a minute or so, my MacBook fan starts to whir. So I'm sure there's some sort of a perhaps GPU-based acceleration. Maybe I could do something with a Translate 3D. To be honest, I'm not that familiar with the GPU-based efficiencies, so I didn't know what to apply in this case. But the overall effect, I think, is quite pleasing. I think it looks actually fairly natural, and it's doing nothing but using CSS animations under the hood, so it's actually fairly easy to put together. And again, just a fun way to kick off the new year, and hopefully this new year is going to bring much better things than the previous year. Fingers crossed.